Hello everyone, welcome back to my YouTube channel. This is Niharika, and here I am with a new subject that is NoSQL. So we'll move on to our topic that is distribution models. NoSQL databases, known for their flexibility and the scalability, often require sophisticated distribution models to handle massive amount of data and user traffic. These models, unlike traditional relational databases, distribute data across multiple nodes, enabling horizontal scaling and high availability. So let's move on to the subtopic in a distribution model, that is single server architecture. First comes the simplicity. This architecture offers a straightforward setup requiring a single server to handle all data operations. It's ideal for smaller applications with limited data volumes and user loads. Then comes the limited scalability. As data and traffic grows, a single server can become a bottleneck, impacting performance and availability. This model struggles to handle high concurrency and large data sets efficiently. Then comes the single point of failure. That is, a single server failure can lead to complete system downtime, making this model vulnerable to outages and the disruptions. So let's see about this threading, that is dividing data across nodes. Horizontal scalability. Threading enables distributing data across multiple servers, allowing for horizontal scaling and handling increased data volumes and user requests. Then comes the parallel processing. By distributing data, operations can be performed in parallel across multiple nodes, improving query performance and reducing latency. Then comes third point is the improved availability. That is, threading enables fault tolerance by allowing the system to continue functioning even if some nodes are down. Data is not stored on a single server, so individual server failures have a limited impact. So let's move on to the next topic, that is master slave implications. First comes the centralized control. A master server manages all data modifications and writes, while slave servers replicate the data for read operation. This approach ensures data consistency and avoids conflicts. The second point comes is the single point of failure. The master server can become a bottleneck, and its failure can significantly impact performance and availability. The system relies heavily on the master server's functionality. Then comes the scalability limitations. The master server can become a bottleneck as the data grows, limiting the system's availability to scale horizontally. Replications to multiple slaves can be computationally expensive. Here comes the combined threading and replication. There are three procedures to be followed, that is distributed data, data replication, and the high availability. Here comes the first point, that is distributed data. Data is divided into smaller chunks and distributed across multiple servers. This approach enhances horizontal scalability and improves query performances. Then comes the data replication. That is, master server manages the primary data, and replicas are maintained on slave servers, ensuring data consistency and availability even if one server fails. Next comes the high availability. This approach provides high availability by replicating data across multiple servers, enabling the system to continue functioning even if a server becomes unable. Here comes the next topic, that is peer-to-peer replication. The first comes is the decentralized control. All servers in the peer-to-peer replication system are equal. They can read and write data directly to their local storage, reducing the reliance on a single master server. Then comes the second point, that is improved scalability. That is peer-to-peer replication enhances scalability by distributing data and workload across multiple servers, allowing the system to handle increased demand efficiency. Then comes the third point, enhanced fault tolerance. Each server can replicate data to other peers, increasing fault tolerance. If one server fails, other peers can still access the data, ensuring continuous operations. Then comes the last most fourth point, that is the potential for data inconsistencies. That is, since there is no centralized control, enhancing data consistency across all peers can be challenging. Conflicting updates may occur if different peers update the same data consistency. This requires careful design and implementation of conflict resolution mechanisms. Let's see the consistency versus availability trade-off. First is the strong consistency. All nodes see the same, up to date at all times. This approach ensures data integrity but can impact availability as updates need to be synchronized across all nodes. Then comes the eventual consistency. Data is eventually synchronized across all nodes, allowing for faster updates and higher availability. This approach can lead to temporarily inconsistencies as data ma- might not be fully synchronized immediately. Then comes the causal consistency, a middle ground between a strong and an eventual consistency. It ensures that writes are propagated to other nodes within a reasonable time frame, balancing consistency and availability. Next comes the scaling with distribution. The first is threading, replication, and the load balancing. Threading is dividing data into smaller chunks and distributing them across multiple servers. This improves performance and scalability. Then comes the replication, creating copies of data on multiple servers, ensuring availability and fault tolerance. It can be used in conjunction with threading. Then comes the load balancing, distributing incoming traffic across multiple servers to prevent overloading any single server. This improves performance and availability. Let's see the final part, that is conclusion. NoSQL database offer a range of distribution models that enable scalability, high availability, and fault tolerance. Choosing the right model depends on factors such as application specific requirements, data volumes, user loads, and consistency needs. By understanding the advantages and disadvantages of each model, developers can effectively design and implement robust NoSQL solutions for modern applications. So, thank you for watching my video.